Hello everyone. In this session, I am going to explain about the working of piston pumps in fluid power system. In the previous sessions, I have discussed about the working of gear pumps and the vane pumps. Now we'll take the working of the piston pumps with the animation and its model diagrams. First, we'll see that is what is meant by piston pumps. Piston pumps are type of positive displacement pumps where the piston reciprocates inside the cylinder. Piston pumps can be used to move liquids or compress gases. Here, this can be used for the make the movement of the fluids as well as the compressing of the gases. Here, our application is for the to supply the liquids we are going to use. Piston pumps are classified as axial design. First one, in that A bent axis design and B swash plate design. And next, second one, radial design. One by one, working of these pumps we will take. The first one, axial piston pump bent axis design. Here, bent axis design means the input shaft and the outlet, the shaft which are connected, those are having the some angles during their connection. There, the shaft what is connected for the operation of the pump, and here the where the pump is fixed, and this is the horizontal axis, and this the rotating shaft, that is the shaft having the some angle with that one, that is the bent axis. And to this shaft the piston rods are connected on the plate, and the cylinders are connected to the its base. And during the rotation of the shaft the piston extracts and retracts. Whenever the extraction is taking place at the top portion, we can see here the cylinder, uh, the inside the cylinder, the suction of the fluid will be taking place through the suction valve. And during its further rotation, the piston will be retracting, moving inside the cylinder, and there it will be compresses the fluid, and thereby discharge of the fluid will be taking place. During the continuous operation, the one after the other, the pistons are number of the pistons are connected, and those one after other the coming of the top portion and gradually at the bottom portion, and thereby extraction and retraction of the piston inside the cylinder will be taking place, and that will supply the continuously fluid to the hydraulic system. This is the working of the axial piston pump of the bent axis design. And here also the model diagram we can see. Here, this is the piston. Okay, the piston A inside the cylinder block, it is connected, and at the top portion it will be extracted. And there the through the inlet port, the fluid will be suction of the fluid will be taking place. And during its rotation, when the piston comes at the bottom portion, that will be completely retracts, and the fluid whatever inside the cylinder will be there, that will be delivered through the outlet port. And for this, the pump, what are the different arrangements are required, different parts are required, those also given here. There is a valve plate, cylinder, a bearing ring here, and the universal link is connected to this whatever the bent axis the piston is there. Okay, the piston and cylinder arrangement and drive shaft. Okay, the shaft will be there connected here. The seal for that, and coupling shaft, radial bearing, drain port, and radial bearing, thrust bearing. All these are connected in this one. The working will be during the operation to supply that the required pressure. All these arrangements are required. Next, moving to this axial piston pump of swash plate design. Okay, this is also axial piston pump of the swash plate design. His swash plate design means the one plate is used. Okay, which is a stationary, that one. Swash plate is a stationary, or it is connected to a shaft also. If the this piston uh, and cylinder block is there, if that can be connected to a rotating shaft, or if the plate can be stationary or plate can be rotating. Okay, then this will can be stationary. Depending upon that, one should stationary, one should move. And here we can see this piston, whatever is there, sorry, swash plate is there. Now on that swash plate, there is a circular plate. There is a circular plate, and inside that one, the slots are provided to connect the piston rods. And during the rotation of this cylinder block, okay, that piston rods are connected. This one that will be extends the piston and retracts the piston. This we can see here at the top portion, one piston reaches, then the piston inside the cylinder that will be extracted, and thereby suction will be taking place inside the cylinder. And gradually, when it will be moving downwards, it will be retraction will be started, and at the bottom position, the completely it will be retracted, and the fluid will be discharged through the delivery valve. That means by the having this the bent the swash plate which is having that particular angle, and the particular discharge of the fluid will be taking quantity of the discharge will be taking place. And here that quantity depends on the angle of this plate, swash plate, at which it will be having an inclination. And again, this can be seen here. This we can see whenever this is rotating the piston in the swash plate, how the slots are provided, that we can see. And the rotation here, the suction will be taking place at this position discharge, and the suction and discharge will be replacing that one. Number of the pistons here we can see that one cylinder, the suction, one cylinder discharge will be taking place continuously, and the angle of this swash plate can be varied in order to vary the flow rate. The flow rate we can vary this one. Here we can see that the variation of that angle also we can see. Like this, the slash plate, the piston pump works, and that also we can see here. Here is the swash plate, and here the piston rods are connected to the swash plate. Whenever at the top, the completely retraction, extraction of the piston is taking place, and at the bottom, retraction will be there. At the bottom position, okay, it is the bottom position here, and gradually upwards here. At this position, whenever it comes, the fluid will be flows into the cylinder. Start the partial vacuum will be created, and that will be draws the fluid into the cylinder, and thereby whenever gradually it will move to the top position, and there the maximum fluid will be extracted. This is the top position, if you say. And whenever starts rotating other side, then the fluid will be due to the retraction of the cylinder piston. Okay, that fluid whatever is there, that will be pressurized into a outlet port, and this is the inlet port, and this is the outlet port we can see. And here the different arrangements or different parts of this swash plate of the swash plate design we can see. The swash plate design is very simple compared to the other design of the XL piston pump or piston pumps. Okay, this is drive shaft. Okay, this is piston, and the fluid from here flows to the valve plate. Okay, then outlet valve plate slot this one, and to the that is connected to the outlet port. Like this, the fluid will be uh, sucked into the cylinder, and that will be discharged in the discharge port. Then next last type of the piston pump is the radial piston pump. This radial piston is very similar to that of the vane pump. Instead of vanes, here we are used the piston and cylinder. The slots and the vane, whatever we have used in the vane plate, vane pump, here the cylinder and pistons are connected. And here the whatever these pistons are there, it will be connected to a that case, whatever the casing is provided, to that it will be connected. And here the cylinder block and the outside casing, whatever is there, those will have the certain offset, and due to that offset, the cylinder will be extracted from the cylinder, and thereby suction of the fluid will be taking place. Whenever it moves to the other end, okay, retraction of the cylinder inside the piston inside the cylinder will be taking place, and thereby discharge of the fluid also takes. And there the valves are connected, the inlet and outlet valves are used here. These are the inlet valve, here outlet valve, which are there. Through that one, the fluid flow will be taking place, and that can be explained here also, the simple plain diagram. And here we can see, here inside this is the cylinder blocks. It consists of the number of cylinders, and these are the pistons which are connected to the casing. Okay, the case or a casing we can see. And here there is offset. The cylinder block center line is here, and this is a reaction ring. The outside ring, whatever the case, we can say reaction ring center line. And the outlet ports are there, and pintle which connects the all the pistons outlets. And here also there is another pintle which connects all the inlet ports, inlet cylinder ports. And that is, there is a reaction ring. That is what I told, that one outside the casing, that is a reaction ring also we can call, where the to that reaction ring all the pistons are connected. And through the inlet valve, during the extraction of the piston, the fluid will be enters inside the cylinder, and whenever that moves to the other side, there the traction of the cylinder inside piston inside the cylinder, it will be taking place, and thereby discharge of the fluid will be taking place. And like this, the number of piston and cylinder are connected here, and due to the offset, the fluid will be enters inside the cylinder and discharges through the cylinder. And radially, the whatever these pistons are connected, and that's why it is called as a radial piston pump. This is also another type of the pump which will be used to supply the fluid for the hydraulic system or a fluid power system. And further, I'm going to discuss these pump efficiencies and pump performance in the next session. Okay. Thanks for watching. If you like, share, subscribe, and comment.